In my last video, I discussed the conservation of linear momentum, but another important related concept you should understand is known as impulse. From a few videos back, we know that Newton's second law can be written as force equals mass times acceleration. Because momentum is equal to mass times velocity, we can actually write Newton's second law in terms of momentum and time. Mass times acceleration is the same as mass times the change in velocity over the change in time. Because we know that mass times velocity equals momentum, we can write this as the change in momentum over the change in time. This tells us that the rate of change of an object's momentum is equal to the force exerted on it. If we rearrange this formula, we can also say that the applied force times the change in time is equal to the change in momentum. This quantity has a name, and it's known as impulse. It tells us that the longer a force acts on an object, the greater its change in momentum will be. Impulse is a vector that can be represented by the letter J. So we can say that impulse is equal to the force on an object times the change in time, which is equal to the change in momentum. Now let's look at the following example problem. In this problem, a baseball is thrown at a speed of 40 meters per second and leaves the bat at a speed of 50 meters per second. The baseball is in contact with the bat for 0.4 seconds, and the baseball has a mass of 0.15 kilograms. You're asked to find the force on the baseball. From the impulse formula, we know that force times time is equal to mass times the change in velocity. This can be rearranged to say that force is equal to the mass times the change in velocity over time. We can then just plug in all of the information that we're given. We see that the mass is given as 0.15 kilograms and the time is given as 0.4 seconds. To calculate the change in velocity, we know that the ball is thrown at a speed of 40 meters per second and leaves the bat at a speed of 50 meters per second. Let's say that the ball is thrown in the negative direction and leaves the bat in the positive direction. The change in velocity is then 50 minus negative 40 meters per second, and we find that the change in velocity is 90 meters per second. Plugging all of this information into the formula, we find that the force on the baseball is 33.75 newtons. I hope this video clearly shows that the impulse formula is really just derived from Newton's second law of motion. Feel free to comment below if anything was unclear, and I'll do my best to answer your questions. If this video was helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.